begin with Module 1, the introduction to the Milton-Madison project. We're pleased to introduce our speakers, Ann Rearick and Kevin Hetrick. Ann Rearick is the Director of Bridges for the Indiana Department of Transportation. She is a graduate of Purdue University and has been working with bridges at INDOT for 25 years. She oversees the bridge design, asset management, standards and policy, hydraulics, and bridge inspection. Kevin Hetrick was the Indiana DOT's project manager on the Milton-Madison Bridge project. Working with the Indiana DOT and consultant staff, he helped lead the preliminary engineering and environmental processes, the procurement, and the design review portion of this design-build contract. In August 2015, he began working for Dietz Engineers as Indiana Transportation Manager. Ann?
Okay, good morning. I'd like to briefly introduce Indiana's experience with ABC. Kevin, if you could advance one, there we go. We began in around 2003 with a bridge slide over a railroad, over State Road 136. Our next big one really was the Madison-Milton. Again, a huge slide. Currently, we're developing plans for another slide. We've done numerous other ABC projects. We just really haven't classified them as such. Next, please. Design build. This is obviously another important component of this project. We first did our first design build in 1998. We've had a very strong design build program. Accelerate 465, Super 70, as well as 3 phases of the I-69 expansion. Currently, we're doing a lot of interstate widening, and we're also starting to try to do best value. Milton-Madison was really our first combination of trying to do ABC and design build together. This did lead to many interesting challenges along the way. Part of design build, you're really specifying your scope of services, really defining everything. When you throw ABC and design build into the mix, you're not sure what you're going to get, and it's very hard to anticipate some of the challenges that might come up, or not having fully defined everything as you went. One of our lessons that we learned was that for the load rating, our expectation, you need to fully define what you wanted. If you don't, you could end up with exactly what's required and have a ratio of 1.0, which leaves you no room for deterioration and things like that on the structure. This project, there were numerous partners involved in it. It was a joint project between the Indiana Department of Transportation and the Kentucky Transportation Cabinet, with very close involvement from Federal Highway through the environmental stage and design, including they awarded us a $20 million Tiger grant. The design build team was led by Walsh Construction, with Buckman and Taylor performing superstructure design and design of most of the temporary works. Burgess and Neifel performing the substructure design for the pier rehabs and designing the lateral slide of the northernmost Kentucky span. Supporting NDOT and KYTC were Micro Baker International and CDM Smith. CDM Smith led the environmental assessment, with Baker providing technical support. Baker led the procurement and the design review and construction inspection, with CDM Smith offering support. Okay, the project is located midway between Louisville and Cincinnati on US 421, and there are no good alternate routes. It's a 50-mile detour, which is 1 hour to make what was typically a 1-mile trip across the river. The bridge connects 2 historic towns that really work as one community together. You have Madison, Indiana. It's the largest National Historic Landmark District in Indiana with 1,800 plus buildings. There's Clifty Falls State Park and other tourist attractions, and there's the Madison Regatta, a population of 12,600. Milton, Kentucky on the other side of the river. It's a historic town. It's susceptible to flooding. It's a rural community divided by a 400-foot tall bluff, population 600. Many people live on one side of the river, but they shop and work on the other. Milton relies on Madison for many of its services. Many of the people that live in Madison cross the river and work in Carroll County, which is adjacent to Trimble County where Milton is. Trimble County, this just has some interesting facts, and Kentucky is a dry county. Indiana has higher tobacco taxes. Usually people find this very interesting. Madison is a very old town on the river with a large historic district. And then the regatta draws tens of thousands of people on the 4th of July weekend. So as you can see, the bridge is really important to the commerce and the lives of the people in the area. Brief history of the bridge. It's a 3,180-foot long truss with two 10-foot wide travel lanes. It was built in 1929 by the J.G. White through the National Toll Bridge Company. It was tolled until 1949, 5 cents for pedestrians and 45 cents for vehicles. Kentucky purchased it in 1939, and they sold a half interest to Indiana in the 1970s for $1. So not a bad deal. The purpose and need of the project. At the time we started the project, the sufficiency rating was 6.5 out of 100. At a 15-ton load limit in 2009, by 2011, due to excessive deterioration, it was a 3-ton load limit. Two 10-foot wide travel lanes couldn't handle the traffic. As you can see from the pictures, RVs take up more space than that. At the time that we had to reduce the tons on the weight limit on the bridge, we had to have state police patrols. Essentially, you were down to an SUV that could go across that bridge. Given that there's campgrounds on the north side of the river, many RVs and campers use the bridge. With the narrow lanes, there were a lot of accidents, and many of them lost their mirrors. Over 15 years prior to the project, both states had invested over $10 million in rehabs and retrofits to the structure and needed to find a long-term solution. Okay, Kevin?
All right. Thanks, Ann. I'm not sure if it was when Indiana bought a share of the bridge for $1, if that was a good deal for Indiana or a good deal for Kentucky, but we definitely share in the responsibility for the bridge moving forward. And as Ann noted, when the project started, this was a bridge that was in pretty rough shape and pretty significant need of major repairs. The two states from the beginning, I guess, appreciated the fact that this was something that had to move quickly. We needed a new bridge, and Federal Highway was also on board from the beginning, valuable partners. Basically, the two states and Federal Highway formed a committee we called the M3T. This was through the environmental phase of the project, where basically leadership from the two states and the feds met bi-weekly. Basically, people that were empowered to make decisions, so we could sit down and talk about the things that needed made, both technically and environmentally, to get decisions made and keep the project moving forward. We got great feedback and involvement from federal resources in Washington, D.C. and Colorado for a lot of the highly technical, complex engineering decisions that need to be made in the projects. We certainly needed their buy-in. We're also very, very active and involved in the public and different resource agencies and historic consulting parties. We definitely wanted to make sure that we had taken all opinions into account to make sure we got the right decision made the first time. We also had a project website, which will probably get mentioned someplace in this presentation, but it's a great resource for information on the project. We had a webcam going throughout construction, and at this point there's thousands and thousands of photographs of construction that occurred throughout the project. We started off looking at a lot of options. The initial, we didn't know that we were going to be doing superstructure replacement. Obviously, do nothing is always an option in an environmental process, but in this case, it certainly wasn't going to meet the purpose and need of fixing a bridge. It was in very poor condition. We looked at rehabilitation, but as Ann had mentioned, the states had spent 8 figures worth of dollars over the previous decade rehabbing the bridge, and it was just really a Band-Aid that was not going to be a long-term fix that was going to do the states any good. Superstructure replacement was basically reusing the piers and just putting a new truss on top of it, on top of the structure. Ultimately, this ended up being a good alternative that met our purpose and need at a decent cost. We also looked at a lot of new alignments. You can kind of see where the bridge is at in the blue square in the middle of this slide. Both the approaches to the bridge, I guess, are non-ideal. US 421 takes a lot of turns through Madison down some pretty residential streets. And then once you get onto the Kentucky side of the river, it goes up a steep hill with a few more turns So we looked at alternatives that obviously realigned 421, basically bypassing Madison and Milton, and also several alignments right in the downtown Madison area. Ultimately, all those were going to be, while they addressed the approach issues we had, the real purpose and need of the project was the structure of the bridge. So ultimately, we want to move forward with a project that was going to meet our purpose and need at the right cost. As we were looking at what criteria we're going to define a successful project for ourselves, we definitely wanted this bridge to be like new, even if not all components of it were brand new, basically us reusing the piers. We wanted a bridge that had a 75-year service life, that was not going to be a headache for either state, that would basically perform like a new bridge. We obviously needed a bridge that was feasible / constructible / affordable, and then also permittable. I showed you some of the alternatives that had long approaches and went outside of Madison. I mean, those certainly to some extent failed on the affordable / feasible perspective. We weren't going to be able to build those in a timely manner, and they were going to cost a lot of money. And we wanted a visually acceptable structure. It was really important to the communities that we had basically there's a big historic district. You got the state park with a hotel and convention area that overlooks the river. People really want to make sure that there was a nice visual signature bridge in the area that would still be visible from the historic district and from the state park. Based on all the information I talked about, we were really starting to hone in on the idea that potentially we could reuse the piers, keep the bridge in the existing alignment, that would be our best bet to meet our purpose and need at the right cost for the project. Early in 2009, I guess 6.5 years ago at this point, the states went out and took cores through each of the piers, all the way down into bedrock, and then performed some sonic logging within those core holes. We determined that the concrete was very strong, 10,000 psi or greater. It was generally sound all the way down. The one place there was a slight anomaly was, and I think Aaron will talk about this a little bit more, but basically a caisson that was sunk during the original construction that was filled in. At the very top of the caisson, there was a slight anomaly in the sonic logging, but otherwise the concrete was strong, solid, looked like great concrete to be able to try to salvage and reuse. We visually inspected the outside of all the piers. Then Baker went to work trying to figure out what sort of work would need done to the piers to make them meet today's design standards. As we looked at the benefits of keeping the piers, like I just said, the piers were in good condition. We felt sure that with appropriate rehab that the piers would have 75 years of service life, and minimize the impacts on the historic properties. Basically, as far as direct impacts, there weren't any impacts anymore. We were able to stay within the right-of-way. It was just essentially building a bridge in the existing footprint of where we already had a bridge. There were obviously some visual impacts, and then with needing a bridge closure, some indirect impacts that needed discussed, but this definitely cut down on the environmental aspects of the project. It's also cost-effective. I think this cost is going to be about 60 to 70% of what it was going to take to build a new bridge on a different alignment, maybe even 50 to 70% of what we would have had trying to offset the alignment a little bit and build a completely new bridge. We're also able to stay within the existing navigational channel. This was something the Coast Guard agreed to. Typically for a new bridge in this area, they would want 900 feet, but given the constraints and different modeling that they had for the river in this area, they agreed with us that keeping the 727-foot channel was an appropriate solution or decision for this project. So that was important to help us keep moving forward with reusing the existing piers. So from all that, we did end up with a preferred alternative of superstructure replacement with minimal approach construction. Basically, there was almost no approach construction, just a tiny tie down in Milton and a pedestrian bridge tie down in Indiana. For all the reasons I had already mentioned, this alternative met our goals. We were able to address the deteriorating superstructure of the bridge. We were able to reduce our historic impacts and our impacts to the right-of-way in general. It was our lowest cost alternative that gave us our 75-year service life And there was also at that time the ARA program from the feds with Tiger Grant availability, and it was a project we could have shovel ready in a time frame to apply for and hopefully receive a Tiger Grant, which our application did end up netting us a $20 million Tiger Grant. So moving forward with this alternative helped us in that pursuit also. So the project, as I briefly mentioned, there's just a small amount of roadway reconstruction, little tie down in Milton at the end of the project, then a small, I guess the Kentucky approach spans, which were to be reconstructed. One of those spans did end up being slid into place by Walsh and Burgess and Nipel. And then there's the large, the truss, 4 spans over 2,400 feet, just about half a mile. Plan was to replace that. I guess the original bridge wasn't 4 spans, but the replacement bridge would be 4 spans. Then we replaced the Indiana approach and the pedestrian tie-down. The existing bridge, as you saw previously, did not have any pedestrian accommodations, but in this project we're going to provide a 5-foot sidewalk. And then at the end of the project, the north end in Indiana, there's both a campground and a public park. The plan is for the sidewalk to tie down into the riverfront pathway that Madison has along the river, and that's also adjacent to their parks and campgrounds there. As I previously mentioned, there's no right-of-way required. All the land at the north end of the bridge there was city-owned by Madison. A little more information. You can see the original bridge had 5 spans for the main truss. It was also the spans were generally inconsistent lengths. The pattern of the truss was not consistent. It was kind of a hodgepodge of a truss design. Our new truss was going to largely take the same shape, be 1 less span, but still kind of the arching movement to the top chord of the truss. The plan was to strengthen each of 4 of the existing piers. Those are the existing piers that would end up being doweled into the caisson, and then the caissons would be doweled into with reinforcing steel about 70 feet deep. The original caissons were unreinforced, and Aaron and Travis will talk a lot more about that in their presentations. Then from there, on the existing pier stem, basically encased with reinforcing steel and a minimum of 2 feet of high performance concrete, low permeability concrete. Put on new pier caps. Put in a new pier 6. The piers at either end of the bridge were pretty damaged by de-icers, pretty high chlorine content, fairly corroded. And then also we wanted to take an extra pier that was in the river and just remove that from the river. So a new pier 6 was constructed, giving us a 4-span bridge. That's basically the bridge, and then obviously entirely new truss superstructure on top of that. This is the typical section of that superstructure. We went from the 20-foot wide out-to-out deck to the new bridge is 40-foot wide, 2 12-foot lanes with 8-foot shoulders. You can see the 5-foot wide sidewalk cantilevered on the downstream side of the bridge. We also put a pretty robust inspection system with a walkway running the length of the bridge, in addition to handrails on all the floor beams and handrails on each of the top chord members also. Definitely want to make this bridge, it's still going to require frequent inspections, even being a new bridge, and we wanted to make sure that that was as inspection friendly as we can make it at a reasonable cost. Here's a couple visuals. These were, I guess, renderings. These were from before the project was even constructed. You can see a general idea of what we thought the bridge was going to look like. We'll definitely have pictures of the as-construction bridge later on. Here's the view. I think I mentioned this previously, but the locals in Milton and Madison really wanted a similar aesthetic to the existing bridge. We did a lot of public polling to determine what they wanted the bridge to look like. And given that the bridge was historic and large historic district, the general consensus was that they wanted a bridge that looked more or less like the old bridge. So we did do some prescriptive language within our scope of services, obviously requiring a truss, even to some extent requiring the different heights of the panels and how the shape of that truss would look. Also, we required an NDOT TF2 railing, which is a 50-inch tall test level 5 rail, but it's got a 2-foot high-strength tubular steel on top of the 2-foot concrete pedestal, basically let people have a better view of the river and look out over the river as they're, I guess, not driving over the river, but any passengers in their car can have a good look at the river while the driver's obviously focused on the road. The piers would all also have a consistent hammerhead shape. We moved forward with the project. Our FONSI was signed in spring of 2010. Permits were obtained that summer. We were also, through early 2010, really working on getting our procurement documents together. We wanted to get that advertised in summer 2010, and basically late in the summer 2010, so construction could start by the end of that year. Again, we had kind of set up a schedule that we said we could hit as part of our Tiger Grant application. We wanted to meet that. We chose design build for a lot of reasons. Up until this point, NDOT had always done low bid design build, not best value. So we were relatively prescriptive on what the project was, but at the same time, NDOT had always had great success in getting innovative ideas from contractors on low bid design builds, and I guess this project now ranks up with the best examples of that, of innovative solutions that were huge wins for everyone involved that came from low bid design build. In this case, we definitely wanted to reduce our closure time frame. We ended up with an A+B bidding, which I'll talk about in a little bit. Also, with no right-of-way impacts, our environmental process got a lot easier, and obviously there was no right-of-way acquisition process. So we knew we were going to be able to pretty smoothly move into design. We wanted to get the project down on the street and get contractors and designers bouncing their ideas off of us to ideally make the project more outstanding. Our contract documents typically include scope of services and special provisions. Those basically outline, this is NDOT's normal design build documents. Those documents outline basically what the project is, what the requirements are. They also outline the process. We end up doing a kickoff meeting and then also allowing the design builders to meet with us twice to discuss design alternates, basically to bounce their ideas off of us and us to give them feedback on if that is or isn't an acceptable design alternate. Then we also put out some contract bridge drawings and plan details. The drawings we put out are typically about 30% plans, stage 1 is what we'd call them in Indiana. They're not really contractual requirements. They're more or less, I think the scope of services says they're there to define our intent. If there's any questions as the prospective design builders, the people proposing the project, are reading the scope of services, hopefully the drawings can shine some more light on our intent for the project. We also, and typically we end up giving a stipend. This goes back to the scope of services, but each design builder submits a proposal where they lay out their approach to the project. Any of their design alternates give us some preliminary plans of their own, and then we score those, and anyone who submits a responsive submittal gets a stipend. We also, in this case, had a lot of project-specific reports, both binding and for information only, that we advertised with the contract. Here's some of the binding reports. We did a study of vessel collision that was performed by Michael Baker. We definitely want to have a prescribed set of rules and basically have everyone playing by the same rules as it regarded barge impacts. The Ohio River is very heavily traveled with large vessels and barges, so we put that out. We also had a wind engineering study done by RWDI. They basically do a site-specific wind investigation and also build scale models of the bridge that they then wind test in their laboratory in Canada to basically come up with site-specific wind requirements for the contract. And then we also made a requirement of the design builder to hire a wind engineering expert themselves. And Walsh, B&T, B&N team ended up hiring RWDI as their wind engineering expert. We also had a geotechnical report. We also put out a lot of other reports that were more or less just things that Baker put together, and I guess CTL, the service life assessment, just basically proving out the concept that the piers could be reused. Obviously, it was pretty heady engineering using the piers. Finite element analysis models were set up to confirm those could be used. We obviously had the slightly reduced wind loads from RWDI. So these were engineering that went into just confirming that this was a feasible alternative to reuse the piers. We wanted to put the reports that have been put together out to help the design builders, or I mean, we had the information obviously. Those also went into developing the structural performance criteria, which are more special provisions, but just kind of defining again what the project was supposed to be, what requirements we thought were needed to ensure that we got the 75-year service life that we were looking for. I'm probably going over on time here. I'll keep trying to talk faster, I guess. Originally, the plan was for the bridge to be able to be closed for up to 365 days. We had provisions for the design builders to provide a ferry during construction. The plan was that the ferry could accommodate up to 240 vehicles. It actually would have been 2 ferries that could carry, it was required to be able to carry 24 vehicles at a time with 5 trips per hour. We've been coordinating with the ferry operators. We put together those requirements. But ultimately, and then we also arranged for a helicopter or other services to get emergency, basically the hospital, the nearest hospital is in Madison. So people on the Kentucky side of the river go to Madison for the hospital. So we need to make arrangements to obviously get emergency services back and forth as quickly as possible. And we had talked about a helicopter for that. Ultimately, the ferry didn't have to be used because of the Walsh MOT scheme. That was probably that was certainly a good thing. The river really went up a lot throughout the course of the project. We would have spent a lot of time with the ferry shut down. Also, as I mentioned, there was a lot of barge traffic on the river. It would have been certainly a lot of coordination, a lot of work to keep that ferry up and running, and even to keep it efficient. But we wanted an alternative in addition to the 1-hour detour, something that would hopefully be a little more efficient and effective than a 1-hour detour. We're not going to talk too much about this. There's also a peregrine falcon, and Charlie might talk about this or someone. Peregrine falcons nest on this bridge every year, and one of our environmental requirements was to keep the falcons on the bridge, or basically have them nest there throughout the course of construction. You can see on the slide that the Walsh team is basically wrapping some of the areas where the falcons could nest in snow fence to keep them from nesting there, and instead we set a net box and a nest box in a specific place on the bridge. Where basically the plan was to get the falcon to nest in the location we wanted them to every year, and luckily they did. Every year the falcon pair came back, nested where we wanted them to. I think it was probably about 15 baby peregrine falcons that were born on the bridge during the construction of this project. Kentucky Division of Fish and Wildlife actually created an award program just to give this project an award for the great work that had been done there. Peregrine falcons were listed as endangered in the 70s. They've been making a comeback, but certainly the state Fish and Wildlife Division keeps trying to do what they can to keep that resurgence going. I mentioned earlier that this project was A+B bidding. We basically assigned a B value of $25,000 a day. If you're not familiar with A+B, I mean, basically the A component is the cost the design builders bid. Their cost to bid the project or to build the project is A. Then they bid, in this case, B was number of closure days. So they bid their number of closure days, which then NDOT and KYTC multiplied by 25,000 a day. Added those two numbers together. And there was also an adjustment for how soon the project could be completed. All the competitive teams bid the early date anyway, so that adjustment didn't matter too much. But basically, we added A+B, subtracted the adjustment, and the lowest overall score or cost was who ended up winning the proposal. We got 5 bids. Cost to construct the project from those 5 bidders were anywhere from about $102 million to $127 million. For length of bridge closure, we had 4 bids that were 365 days of closure, which was basically the maximum allowable. 4 of our design builders said they needed the entire amount of time. And then the one proposal, the Walsh, Buckland, Taylor, Birch, and Lample proposal, said they needed 10 days of closure, which we were obviously aware of that, having talked to them through the design alternate meetings, but it was an amazing idea they had come up with that allowed them to dramatically slash the amount of closure. For costs, they were actually I think the Walsh bid was about $103 million, so they're about $1 million over the low bidder for cost, but certainly with the A+B, they were easily the winner of the project and came away with the work. That team, as has been mentioned a couple times, was Walsh Construction as the builder, and Burgess and Neipel and Buckland and Taylor as the designers. They'll all be doing presentations later on today, so I won't spend too much time on that. I'll also spend a decent amount of time talking about this. I mean, their plan is basically to build the new truss on downstream temporary piers while keeping the existing bridge in traffic, strengthen the existing piers while that was going on, eventually shift traffic onto their new truss on the temporary piers, remove the old truss, and then slide the new truss into place. Basically, the plan was for that all to be able to occur in 2 different closures, but for a total of 10 days or so. We talked about that quite a bit as a DOT, and certainly we felt that was going to be a safe alternative. They basically had to meet all the wind loading barge impact requirements that they would have had to meet for a permanent structure. Basically, the only leniency they had was whatever leniency was allowed for temporary structures by LRFD, by AASHTO. And also, we knew that Buckland and Taylor had been involved in some slides before. Old Capilano Bridge being a bridge they had slid up in the northwest. Certainly not a half-mile long like Milton-Madison, but they were coming from a position of experience. And that pretty much wraps up my slides here, and I think I'll be turning it over to Ann for the next 4 or 5 slides, and then we'll take some questions.
Okay. Thank you, Kevin. Due to the complexity of the project, while the ultimate structure is, a standard truss, how it was built and how we retrofitted the piers, we felt that this was a complex structure. As such, we developed an inspection and maintenance manual for the bridge. This is to assist with each inspection. The manual is very complete. It has a description of the bridge, including its history, describes the access to the structure, identifies the fracture critical members, weld locations, and it notes that there's no category E, E prime, or F details in the superstructure. One of the lessons that we learned, and again, this was the combination ABC design build, as you're doing your scope of work and setting out the requirements for qualifications, this manual really needs to be developed by a bridge inspector. They need to play a strong role. It probably would have made it go smoother as we went along. The manual also notes the location of where the temporary connections were on the piers. These are now grouted over locations. It's something that a future inspector may not know about, so they wouldn't know to look for it. So we wanted to make sure the manual noted all these things that were a little bit different due to the type of construction. There were some members that had been damaged during construction and then were not repaired. It notes what these members were and what analysis was done and why they weren't repaired. It covers the suggested maintenance. It also has suggestions on future repair work. How would you replace various members on the structure? The initial inspection of the bridge was performed on August 21st, 2014. This was completed prior to the final punch list, and there was still ongoing work, including touching up the paint. The pedestrian rail was not installed. Again, kind of lesson learned, and I believe this is going to get covered later as well, is that you probably want to wait on the final paint job until the construction is almost complete. Just due to the nature of the work, things get dinged up, and you do have to come along and touch it all up. Both a routine and a fracture critical inspection were performed on June 5th, 2015. Again, it noticed some distorted members. These, again, had previously been evaluated, determined that they were okay. Did note some areas of ponding water on some of the upper and lower cords, and this has been remediated. And, overall, I think this was just an awesome project. I think it went very well, and I think we've got a great bridge in, a very efficient manner.
Thank you, Ann and Kevin. Excellent presentation. We'll now begin the Q&A session. We received a couple of questions during Ann and Kevin's presentation. First, how did you determine the $25,000 per day B value?
That always has to be supported by actual numbers. We certainly the cost of the ferry was something that we were considering. I mean, every day that the bridge was open, we're going to have a ferry operating, and that was a significant cost that would obviously be out there. We'd also taken into account just our general administrative expenses on the projects, out inspecting, having people out inspecting the work, and certainly the quicker we could get the project done, the less money we'd have to spend on that. And then also user costs. We had talked about a decent amount of people would be taking an hour detour. There'd be another good chunk of people sitting around and spending some amount of time waiting on a ferry. We quantified the user costs plus some amount of inspection costs plus the cost to operate the ferry, and basically came up with a number in the $25,000 ballpark, and that's what we used for the B component.
Okay, thank you. We're now at the end of the first 40-minute module. Thanks again to Ann Rearick and Kevin Hetrick, and to all who participated in the first module.